Enduring Understanding 2.4 is all about the mean value theorem. In short, the mean value theorem guarantees that there is a point in the interval where the instantaneous rate of change equals the average rate of change. There are two main hypotheses that must be verified before you can apply the mean value theorem. F must be continuous on the closed interval from A to B, and differentiable on the open interval from A to B. Then there must be some point within that interval where your I rock at that value is equal to the A rock over that interval. So here are a couple visual examples here. I've highlighted where the A rock slope is equal to the I rock slope at some point in the interval, or sometimes it might happen more than once in the interval. So let's go ahead and try an example below. First, we're asked to verify the hypothesis of the mean value theorem are satisfied, and then find all values of C in that interval that satisfy the conclusion of the theorem. So we can see that f of x is a polynomial function. So polynomial functions are both continuous and differentiable. So for our hypothesis, we state f of x is continuous on the closed interval and differentiable on the open interval. So by the mean value theorem, you have to state which theorem you're using. There exists a C value, an element of the open interval, such that the derivative at that value, or the I rock at that value, is equal to the average rate of change over that interval. So now that we have verified the hypothesis and set up the formula for the theorem, let's go ahead and calculate to see what those C values could be. So f prime of C is the derivative for C. So that's 2C minus 1 equals 20 minus 12 over 8. So that makes 2C minus 1 equals 1. So now we can solve for C. 2C equals 2. C must equal 1. And C is an element of that open interval from -3 to 5. So if you are using the mean value theorem, I'm going to highlight what's required. First, you have to state f is continuous and differentiable. You have to say which theorem you're using and that there exists a C value such that the instantaneous rate of change is equal to the average rate of change. And then if they ask you to find that C value, you must solve for it.